So, hi everyone, thank you for coming. And today I'm going to talk about how we predict the purchases in mobile games. And a quick introduction about myself. My name is Dima Sebastian, also known for some reasons Dave Savio. And before that, I was head of AI and chief product officer at Ghost Data Lab. We raised 5 million and created a voice assistant for gamers. The startup was successfully acquired in 2021. And after that, I took a course, this business, and was a senior data scientist at North company here nearby on Savio Protective. Oh, sorry. Is it better? Yeah, it's a game development company here.
Is it on?
Yeah. Yeah.
Okay, so.
Yeah. Maybe it should be better like that. So yeah, it's a game development company here in Vilnius, Lithuania, and they have more than 500 million downloads, and they create mobile games. And yeah, right now I'm a founder of Artifactory. It's my startup, my passion. We create art for games with neural nets. In fact, we fine-tune these neural nets to create digital assets. And today I'm going to talk about the period of time at Nordcard. So here's the problem. Suppose we have a player in our game. And let's take a look at this chart. Here we see his transactions on daily basis. Like at some day he spends $10, after that he may spend $20 or $0. And the question is, like, how much money he will spend in the future? And why this question is important? Because in mobile games, usually we have less than 10% of players who pay for something, even sometimes less than 1%. And we need to work with these players, we need to retain them, and sometimes we may offer them some discounts, or we may be a bit harder for them. Yeah, sorry about that, business. But yeah, and we want to estimate somehow the probability of purchase in the future. And the solution is it's just this table with predicted probabilities of purchases. And here's how it works. So at this line, it was like 27th of February this year, and the probability of purchase was just about 6%, because of this huge gap between the last transactions. But after that, we see that the probability increased up to 63% because he actually made the transaction. And after that, the next day again, the probability increased up to 90%. What does it mean? It means that our model thinks that in the next 7 days, the probability that this guy made the transaction is, say, 90%. And after that, we see some decreasing trend because he paused with purchases and he just played our game. And using this data, we can make this magic in our game. Let's say if the probability is 50-50, then we can make some offer to this player. And yeah, so how does it work? At the beginning, we had the following stack of technologies. We had Python as our language. We had ClickHouse as data warehouse with all our analytical data. Apache Airflow as orchestrator, and Apache Superset as the dashboard system. And we had some requirements. First of all, we want to build a reproducible system. I think you know this cool story about common data science practice when you hire some data scientist and he trained some model on Jupyter Lab or Jupyter Notebook on some CSV data, put this in production, and left the company, and nobody knows how to reproduce his work. So this is the problem, and we want to escape that. So we want to retrain the model on new data on weekly basis, for example. And also we want to be flexible. We want to experiment with the data set, features, with our target, with our models. So we still need to be flexible, and we want to train our model on, let's say, a sample of 100,000 people in 5 minutes to experiment pretty fast. And also, there is a requirement that the inference time should be like 5 minutes on the whole user base, because you want to use this model on hourly basis, for example, and update your predictions pretty frequently. And so yeah, these are our requirements, and as a result, we have the following stack of technologies. So we added ClearML. It's an MLOps solution that helps you to store all the artifacts, like your binary file with the model, your configs, your metrics, and it stores all the information on AWS S3. So it's just a simple S3 bucket. And to validate all the configs, we use Pydantic because yeah, it's great. And as machine learning library, we use CatBoost because here we work with tabular data, and as you know, gradient boosting on decision tree is a great algorithm with tabular data, and CatBoost is it's a great implementation of this algorithm, so that's why we use it. And here is a pipeline. It's pretty simple. We just want to collect data for training. We want to train our models and play with hyperparameters. And we need to use this model in production and score our users. So, in fact, it's 3 DAGs in terms of airflow, and we will go through them. So the first one is data collection, and in my opinion, it's the most important DAG. About our data set, so how it was designed. The primary key of this data set, so the identifier of the row, it's an identifier of a user and some data time timestamp. So we just take the state of this player at some moment in time and predict his transactions in the next 7 days. In fact, we predict, like, will he pay or will not in the next 7 days. And the cool thing here is that you can sample lots of rows in the following way, and you can create a data set with millions and hundreds of millions of rows and train a pretty large model on them. And we don't want to process data with Python because it's pretty slow. And as I mentioned before, we have ClickHouse as a data warehouse, and it has tons of useful functions for aggregations, and yeah, it's pretty fast. So the idea was to process all the data on ClickHouse level, and in this DAG, what we do, we drop completely the previous version of our training data, because sometimes we want to change the schema and new features, and we create it from scratch, and we can recreate these tables because we use historical data. And after that, in parallel, we insert data from different games. So we have 6 games here, and we don't want to mix information from different games, and when we see transaction from the player, it might be from one game or from another, and we want to separate them. And this is how it works under the hood. In these nodes, we have on the left side we have model config. It's a Pydantic model with let's say features of our model. For example, here we have target days, and this field it shows the horizon we want to predict for. And you can use 7 days and predict for the next 7 days, or you can use 28 days and predict for the next 4 weeks or a month. And this is just one thing you need to change, and voila, you have the completely new data set, and you can train on it with your model without any other changes. But also to do that, we need to deal with SQL queries. And here what we do, we use Ginger filters. So you can render these queries using these model config. And this is from one side, it's sometimes harder to debug these queries because you need to render it and trying to understand what's going on. But the other side is that you can change your model experiment pretty fast, and you still have just one template, and you can work with them. So after we collected data, we have this training pipeline, and the idea is, again, pretty simple. Of course, we can optimize our hyperparameters with some smart techniques like bias and optimization, but usually it's a sequential process. And here, because we have a cluster of nodes, we can just run in parallel several experiments with different hyperparameters, and we just store all the results in ClearML. So on the left side, it's a screenshot from Airflow, and we just run these experiments with different parameters, and after that we select the best one. But in each node, we go to ClearML and save all the information about the experiment. It has information about commit hash, it has some metrics, and of course binary files about models and model config. So you can reproduce the experiment, and also you can go there and see the details about this experiment. And later in this node, in model selection, we just go through last experiments in ClearML and select the best one according to our metric. Here is a sample of charts. So we just render these charts during the training process in nodes in Airflow and store them inside the ClearML experiment entity. And after that, you can you selected the best model. You can go and explore it. You can see different confusion matrices for different thresholds, or you can see the chart with the most important features and try to estimate the impact of new feature you recently added. And moreover, many people can experiment in parallel, and we will just select the best model from all of them. After that, after we selected the best model, we want to apply it to the real data to our users. And as I mentioned before, in ClearML you have the link to S3 bucket where you can download the binary file with your model, and using config, this model config, you can reuse query template from previous data collection step to collect new data for today or for yesterday, and apply your model again in parallel to different games. And here is the difference between this chart and, for example, data collection, that we don't drop our table. We collect and store all these predictions in ClickHouse, and we don't drop previous predictions. Instead, we have, let's say, created at cube, and as a result, we can see these predictions in dynamic. And in parallel, we score different games. And as a result, we have such a dashboard with monitoring on Superset. And here you can see some information. Well, this dashboard is for one user. You can change the ID and see transactional data from this user, or you can see the predictions and use this information to make decisions. But also we store all these predictions in ClickHouse, so you can go there, or you can go to the API and use them in your production, in your workflows. And also using this dashboard, you can create some alerts, some monitoring. If anything breaks, you will know about this pretty soon. That's it. Thank you for your attention. Here are my contacts. You can scan the QR code and find me on LinkedIn and other platforms. Also, I'll be in corridor after this talk, so you can ask all your questions. So, yeah, thank you for your attention.
Let's start with the questions.
So the company obviously cares about revenue, and you are focusing on building the model to predict likelihood of purchase. Why not, let's say, so what's the point? How do you use it? How do you use likelihood? You can just maybe use a regression model to predict revenue. That's what.
Yeah, the idea here is not to just predict this revenue, but you want to use these model to affect your revenue, and you want to earn more. And the idea is to find players who are somewhere in between. There is still a chance that they will purchase something, but they need some stimulation, and we want to find them at the right moment and offer them something in our game, or make this game harder. And as a result, we will increase the chance that they will pay more in our game. And also we can use these predictions to prioritize, for example, tickets in support. When we see some problems from our players, there are usually tons of players, tons of problems, but we can solve as faster as possible problems for players who are likely to play more, because it's important for our business.
Do you have any recommendation on the resource what you can find about that business side and marketing, how it interacts with data science? Because that's what motivates you to build these models.
Yeah, well, this is a hard question, and I'm a spy in the world of data science because I also have some business experience, and sometimes I just switch between these roles. Sometimes I'm in the hat of manager, sometimes in the hat of developer / machine learning engineer. And just from, you need to communicate with different departments and understand their problems and understand the problem of your business and find the solution of these problems. So this is the best way.
How many models are you doing, and what is the gain from the hyperparameter tuning? So, do you go from 80% plus to 85 or 90 with tuning?
Yeah, thank you for your question. We usually tune like 20 models in parallel and with different parameters just from random search. And well, there is some gain from that, but it's like a few percent. And usually features are more important than these fine-tuning in our case. So we have like some golden features, and the best way to increase the accuracy is to find more such golden features. Because, for example, with the purchases, the number of days since last transaction is the golden feature that helps you to predict these purchases in the future.
How do you measure how much of a revenue increase comes from specifically having the intelligence from the model?
Yeah, you can, thank you for this question, and you can run an A/B test in your game or in your department, and for some people you can do nothing or, let's say, make random predictions, and for another part you can use your model, and as a result you should see the difference in metrics like conversion into repeated purchases, and yeah, this is how we can track the business efficiency, the business effects.
Maybe two questions. So you mentioned golden features and said that days since last purchase. Maybe you can mention several other. And another question, for example, if user just joined and he didn't do any purchases, does it, how do you deal with those users?
Yeah, thank you for this question. So if the user just joined, we have no information about him, and we just don't use this model. It's easier for us to wait for his first transaction. So the idea is like, if he have no transactions right now, our model think that the probability of the next purchase is 0. Of course it's not, but right now it's the part of our pipeline. And our golden features, well, here we use a lot features with aggregations on transactions, like count your transactions and their value, even some quantile. And here is the next feature, is the ratio between the number of transactions, the total number of transactions you have today, and 28 days before. So we can see this growth, so how many transactions you make. And yeah, also there are some other features like game ID. Of course it's important because we don't want to maintain several models for different games. We just want to have one huge model and apply it to all the games, so that's why game ID is also pretty important. And I think I can share these slides somewhere, somehow, and you will be able to check some of these features. Great.
So for the user who is likely to pay, do you categorize them and offer different stimulus?
Yeah, this is the idea. In fact, if the probability of purchase is pretty high, maybe you don't need to do anything because it's okay. And if it's really small, it seems like it's late to do something because maybe he left the game or he's not interested in your items anymore. So you need to catch him somewhere in between and experiment with features in your game or your workflows, and try to stimulate.
And do you use the data only from the game or use some external sources to categorize?
No, only the data from the game, and in fact we don't know who our users are. I mean, we don't match them with the real people in the world. We just see their behavior in game, some analytical log, and using this information we can predict this stuff.
This model sounds like quite general churn prediction.
Yes.
Essentially. How would you say it would be difficult to take this and transfer to another industry?
It's pretty easy. You just grab it and transfer to another industry. All you need is the data, but the idea and the whole pipeline, you can just transfer it without any problems.
Does your model take into account seasonality? So let's say Christmas season and whatnot.
Yeah, this is the hard question, and yeah, during dataset collection we add these periods with Christmas and Halloween, but right now I think there is no feature like holiday, like binary flag, is it Halloween or Christmas? And maybe we will need to add this feature because yeah, we have these spikes on. Thank you.
Can I ask, do you have some connection to user acquisition team in your model so it can be actionable for this particular marketing campaign, whether that is successful or not?
Yeah, that's a great question. Thank you. And the problem is that the problem with user acquisition is that all these laws around GDPR and iPhone restrictions, sometimes it's really hard to match user in your analytics with the channel came from. So, for example, when users come from Facebook on iPhone, usually we attribute them as organic users because we just cannot match identifiers. And as a result, it's really hard to use this model to optimize our marketing channels. It would be great, but it's hard. But I know that there are some models that try to deal with that. It's in our case. Yeah.
So how do you choose which users get this in line, and do you choose some metric and try to optimize that? Is it a rule or something? And how do you choose the metric you want to optimize? Which users get this in line based on this model?
We want to optimize conversion to repeated purchases in our game. So we work with the segment of users who have at least one transaction in our game, and how to stimulate them. It's a question to game designers and these content production teams because it's their product. We just show them the opportunity, and after that they decide how to use it. So this is how it works. But yeah, usually you can just at the beginning you can apply some rule, like if the probability is somewhere in between 0.5 0.7, then offer a discount. This is the simplest A/B test you can run. Oh, thank you so much for your questions.